All right, so Foundations of Math 10, section 5.5, we're going to talk more specifically about graphs of relations versus graphs of functions. I'm going to take a look at some properties, take a look at what they look like. So if we take a look at, where am I going here? Right here. All right, this is from your textbook here, and it gives two graphs, okay? Joe, here's your graph, all right? And here's Alice's graph. I'm not sure who Alice is, but someone. In an environmental study in northern Alberta, Joe collected data on the numbers of different species of birds he heard or saw in a 1 hour period every 2 hours for 24 hours. Don't let all that, it's quite wordy, just was taking data every hour, taking some data on the number of different birds that he heard. Alice collected data on the temperature in the area at the end of every 1 hour period. They both plotted their data, okay? Two different graphs here now. So if we take a look at Joe's graph here first, you see that time is the independent variable, the number of species is the dependent. That makes sense, right? Because time just ticks on, right? That's kind of where we start. Time is ticking on, and so you are measuring and plotting, gathering data on the number of birds that you hear or see, right? So that makes sense. Hopefully that makes sense. So, okay, so at 600 hours here, okay, 6 in the morning, looks like, Joe heard 25 different species of birds. That's amazing. At 8 o'clock, a little bit less. What would you guess this number to be if you had to guess? 24 maybe? Okay. This one's 20. This one might be 11. Okay, and so on. All right, so it dropped off a little bit here, right? And then, for some reason, about 4 o'clock, boom, we've got lots more activity here, and it drops off, and in the evening and overnight, quite low. That makes sense. Okay? And of course, 6 o'clock in the morning is the largest number, is the highest activity, which makes sense for birds in the morning, chirping in the morning, right? All right. So Alice recorded temperatures. Let's go over and take a look at her graph here. And it seems to say, just in general, if you look at these data points, all right, it seems to say that the temperature is rising to about this time of day, which would be on a 24-hour clock, it'd be 2 o'clock in the afternoon, 1400 hours. And then it starts to decline and gets its lowest sort of overnight between midnight and 2 a.m. So that makes sense to us as well, I think, right? It's hot during the middle of the day when the sun's out and out for a long time. Then the sun starts to go down, the rays are a little less direct, and then overnight with no sun, the temperature the heat seems to dissipate, and it gets colder. All right, so the question is, now if we take a look at these questions below, does each graph represent a relation? Do each of these graphs represent a relation between two things, two variables? Yes or no? Yes, of course, because each point represents sort of a piece of one of the variables and a piece of the other variable. So at this time, we have this many species of birds, right? So it's how two things are related. So they're both relations, okay? Now, are both of them functions? And how can you tell, okay? So someone said yes, all right? You want to tell us why you think that they are functions? They are both functions, you're right. Okay, yes, very good. Each item in the domain, okay, so each domain element only has one range element associated with it. Absolutely correct, yes. That's the definition of a function. Exactly. Same over here, right? Each element in the domain only has one element related to it. So what would it look like? What would it look like if it was not a function, either one of these? What would it look like? What would the graph look like? If it didn't have just one, it would have more than one, right? So what would that look like? Anybody? Let's say it wasn't a function and I looked at number 14. What might I see? What might I see on the graph around 14 here? What might I see? Yeah, yes. Multiple points in the same. Now, rows are usually sideways, so I know what you mean. You said same row, same sort of vertical row, vertical column, right? Exactly, yes. If it wasn't a function, at some point in here, you would see maybe more than one dot in a vertical column. So we might have another dot. Now, would this make sense? No. This would not make sense at all for this graph because, how can we have two measurements at the same time? Well, you're just adding up all of the different sounds that you hear or the birds that you see, right? So it only makes sense that there's one point. But what I was asking is, if this was not a function, what would it look like? And that's exactly right. You might have more than one point on a vertical line, okay? So because a vertical line, any vertical line that we can draw through this graph, only passes through one point, that means it's a function. That is the first major thing that we need to know from this section. And it's called the vertical line test. So let's take a moment to write out the vertical line test below. The vertical line test is defined like this. Any vertical line, that's a straight up and down line, okay, that's drawn on the graph of a function, would pass through at most one point. So only one point. Now, I put at most because I can draw a vertical line right here, and it wouldn't pass through any. That doesn't mean we have a problem. But any vertical line you draw would at most pass through one point. Okay? And so if this were the case where I had 1, 2, 3, 4 points in a vertical line, then this would not be a function. Okay? All right. Let me draw some more examples here for you. For example, here's a graph. Let's draw a continuous line graph here. Okay? Or this is a function. It's not a straight line, but this would be, I kind of gave it away. I called it a function. But let's test to see if it's a function. And what you literally would do is you could take your ruler, all right? Or you could just, most of the graphs will have sort of vertical lines you can actually see. But you would draw any vertical line, as many as you can, as many as you want, and each vertical line would only pass the graph, only pass through the graph once. You see that? There's only one point of intersection between the vertical line and the graph. So this is definitely a function. Okay? It's a function. Let's draw a non-example of a function. Any ideas from you before I draw it? What's something I could draw that would not be a function? Any ideas? I'm just wondering. Okay, don't worry about it. What about this one right here? Now, would you agree with me that this strange sort of line graph here, would this be a function or not a function? Let's see. I drew a vertical line and it only passes through once. So I say it's a function. What do you say? You're shaking your head, of course. Could I draw a vertical line that passes through more than one spot on the graph? Yes. And all you need is one. So vertical line, it's close to vertical. But look at it, passes through 3 points of the graph. See that? So this means that it is not a function. Not a function. Why? Because it does not pass the vertical line test. And that's the wording that you'll hear. It does not. And if we call it a test, it's pass or fail, right? It does not pass the vertical line test. All right? And that's literally, it's really easy. If you're looking at a graph, you can tell whether it's a function or not just by using a quick vertical line. All right, so this goes for graphs that have just points or graphs that have the points connected. Now, there was a question I was going to ask you about these graphs that I neglected to, but one of the questions in the text, which, let me see if I can just go back there real quick. Nope. Where is it? Okay, so right here. Which of these graphs should have the data points connected? Explain. One of them should. Do you have an answer for that? Okay, you're saying Alice's graph should have the data points connected. So Why would you say that? What's your thought process there? Okay, okay. Yes, very, very good. I would agree with you now. If we connected these points, and again, sorry, drawing freehand, not doing a great job of connecting all the points, but this is an aside for you. It's a little tip for the future. When you're connecting points in math or science, do not make straight lines between all the points. Most of the time, that is not appropriate. I know you're wondering why, but I'll tell you why later. You should always try and draw a very smooth curve. Why? Because of exactly what you said. It's that the points in between these points that are plotted, they totally make sense. And it would be very, very likely that between, what is this, 6, 8, 10. So at 9 hours right here, that the temperature would be somewhere between here and here. That is very logical. Now it may not be, right? Because we could have some kind of spike here, and it could look like this, right? If we were taking data points every minute or whatever, we could see something like this. But it is reasonable to connect the points on this graph because the temperature has to go from here to here. The points in between make sense. Over here, you would not connect the points because of exactly what you said. The number of birds are not necessarily related, okay? So it wouldn't necessarily be a good guess that this point right here would fit right in there. It could be up here, it could be down here. If you drew the lines between this, I wouldn't say you were 100% wrong, but I would agree with you that this one, connect the points, most likely. This one, it's debatable. You'd probably say no because these are discrete points. They're different. However, someone might come along and say, well, Mr. Maxwell, does not it make sense that at 10 o'clock, if you hear 20, and at 12 o'clock, you only hear 11? Does it not make sense that somewhere in between here that you might have heard 15 at some point, maybe right about here? And I'd have to say, well, I guess it could, but there's no relationship between the number that you heard at this point and the number here, right? All of the points in between, that doesn't necessarily make sense. So maybe that's not a completely definite answer, but I like the way you're thinking, and that's what I want to challenge you with. Yes, and probably no here, I would say, to connect these points. Okay? But you probably could have an argument for that one as well. All right, as we move on, let's take a look at our text. All right, example 1. Which of these graphs represent a function? Justify your answer. If you were to look at these graphs real quickly, could you tell me A or B? Which one's a function? Which one's not? Which one? Which one is? B is, and A is not. Why? Because if you were to draw a vertical line right here, boom, you'd hit 3 points. Over here, you'd hit 2. So the relationship between shoe size and height is not a function. Why? Because two people with of different heights could have the same shoe size. Or someone with size 9 could be this height, but they also could very well be another height. Like someone else could have the same shoe size, but a different height. Totally makes sense, and that is the case here. This one, the year versus the world population, okay, at the end of given year, there's only one possible answer, right? There's only one answer. Boom, this is the number. Doesn't make sense that, there could be several different values there. Well, there could be a range if you're not counting every single person, depending on which second you do the calculation, right? But there really should be just one number. It doesn't make sense that there should be more than one number. So, yes, looking at the graphs, awesome. Okay, what about this one down here? Function or not? Function, yes. Draw any vertical line, you only pass through one. What about this one? Not a function. There's lots of vertical lines that pass through more than one point. Awesome. Okay, here's your solutions right there. Awesome. You guys rock. Okay, what about graphs that have lines? Okay, they're continuous. Function or not? Right here. Function, yes. Function. Function or not? Looks like it's a function, right? Again, you draw a vertical line, function. Yeah. It gets a little bit iffy right here, doesn't it? It's like, what is happening right here? Boy, that looks like maybe it's not a function. Well, your best guess You see how it's creeping over, okay, at this point, and if this is a half of a circle, it looks like a half a circle, right? If it's a half of a circle, then if it stops right here and doesn't go down any further, then it would be a function. If this went down further and looked to kind of double back over itself, then it wouldn't be, right? But yes, your best guess here would be that this is a function, even though you're not really 100% sure what's going on here. But yeah, you would guess that that's function. Very good. Okay, function, 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 function. Okay. Anyways, yep. Okay, what else do we need to know about this? Okay, if you see function notation, what does that mean? That means the relation is a function. Yeah. Okay. So there you go. You're connecting the notation now with the graphs. Straight lines are functions. Okay. Let's talk a little bit about domain and range here. What's the domain for this graph right here? What is the domain? So let's just zoom in on this one here. Okay, the quantity is time, yes. Now what is the actual domain? Be more specific. All values between, I'll start off for you. All values between 9 and, 11. Well, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So all values between 9, because this is where this graph starts, and 1600 hours on a 24-hour clock, right? Do you ever get that? The domain quantity is time. Excellent. The independent variable is time. Excellent. The actual domain, you would say, because this is a line that's a continuous line, you see, you would say all values between 9 and 1600 hours. Okay? Now, over here, look at this one right here. There's no line connecting the points. So if I asked you for the domain here, you wouldn't say all values between 10 and 1600 hours. Instead, you would say the domain elements are 1000 hours, 1100 hours, 1200 hours, 13, 14, 15, and 1600 hours. You'd have to list them separately. Okay? But over here, when the line is a continuous line, you can say all values between here and here. Make sense? Are you picking up what I'm putting down? Yeah? Okay. What about the range? Quickly, what about the range for this one right here? What is the range for this function? Oops. Let's zoom in. Okay, sorry? The range here. Yeah, here's the hint right here. Range. Now you have to kind of guess here, I guess. 4, 6, 8, 9. Let's say that's 9ish, 0.9. Anywhere between what? 0.9 and, okay, very good. Now you're looking at the vertical, right? Up and down. So anywhere between here, 0.9, and 1.5, I would say. Very good. The range, all values between 0.9 and 0.5. Would the values include 0.9? Yes, because it's a solid dot there. Okay. So this is all good stuff. That's. Have you guys heard this before? Like including a point and range, all values between. Is this stuff you've heard before, or is this kind of new? New? Awesome. Okay, good. I will spend more time on that as we move through both math and science with you. But anyways, if you can kind of understand that now, again, you guys are pre-AP too, right? So you need to know about things a little bit earlier, and you need to know how to do things. You need to know how to think a certain way a little bit earlier because, A, you're going to be taking calculus in, first semester grade 12, and so those that are not in AP, A, may never get to calculus right now, but they're going to be taking classes that you're taking, they're going to be taking them maybe a year later, right? So that's why, kind of pushing you to think certain ways. That's good. All right, back to here. Okie dokie. Do you guys have any questions so far? Let's take a look at this example then. Here's a graph of a function f of x equals negative 3x plus 7. Do you guys understand, first of all, let me ask you this. Do you understand how this function, this mathematical expression of the function, and this line, do you understand how they're connected? Do you understand that? Would you be able to look at this and look at this graph and say, yes, I know that they're the same? Are there aspects of this graph that you recognize, and aspects of this sort of function right here that you recognize? Can anyone tell me? Any brave souls want to say, yes, I know that line is the representation of this function because? What's one thing? Okay, if you plug a number into x, then it should relate to the y value. So if x is 2, negative 3 times 2 is negative 6, plus 7 is 1. So that looks like 1 right there. Okay, very good. Let me zoom in. Yes, you're right. Plug in 2, you should get 1. There's 0, 2, so 1 is right there. Okay, any other aspects of this line that you can directly relate to that function? You're right, by the way, but I'm searching for something else. And again, this may be, you may not have heard about this before, but has anyone heard about the slope y-intercept form of a line? No? Okay. All right, I'm just checking because, you know, we'll spend some time on that. That's coming up here, different forms of a line. I just want to know. Okay, no one's ever heard of that before? The slope y-intercept? Okay, have you ever heard of y equals mx plus b? No? What are they teaching you in grades 6 and 7 and 8 if not that? I'm just kidding. I'm like, what? Okay, no, listen. I will save the exciting answer to those questions and more later. Because I don't want to overwhelm you now. Okay? You're welcome. Okay, very good. Okay. Okay, so let's just get to the actual question then. Determine the range value when the domain value is negative 2. Okay, the domain. All right, keep paying attention here. We're almost there. The domain is what? Is it x or f of x? X, good. So when the domain value is negative 2, that means I'm looking for what is f of x, the range value over here, when the domain value is negative 2. So you just plug that in, don't you? Here's the answer down here. Look at that. So f of negative 2, negative 3 times negative 2 is positive 6. Plus 7 is positive 13. So the range value that's associated with the domain value of negative 2 is 13. Look at the graph. Negative 2, we have an associated value on this line of 13. Get it? Okay. Here's another question for you. What is the range value associated with the domain value of 0? So if x is 0, what is y, or f of x? What is it? 7. Why? Because negative 3 times 0 is 0, plus 7 is 7. 0, 7. See that? 0, 7. Boom. What is this point called? Again, you might not know this, but I'm going to ask. Okay, this is the y-axis. Very good. What is the point at which the line intercepts the y-axis? What's that one called? It's the y... No, this is the y-axis. It's the y... Sorry? Intercept. Yes. Have you ever heard of that? Obviously, one person has. What would this one be called? The point where the line intersects the x-axis. It's the x-intercept. Oh, wow. You guys are not intersect. No. It intersects. Yeah, that's S-E-C-T-S. Okay, don't get distracted here. Intersects the x-axis. There's a lot of x's in there. Okay. Too many. Okay, sure. But it's called the x-intercept. PT. Anyone follow football? Football? It's an interception. You see that? Interception? That's where the ball connects with the wrong guy, but it connects. Interception. So it's the y-intercept here. The x-intercept. Whew. Okay, good. Always like it when we can bring some kind of football analogy in there. That's great. Okay. Any questions so far? All right, let me get you to your. I think you're ready for your assignment here now. Okay. You think you are too? Well, that's good. I'm glad you think you are. Very good.